All right, let's get right into it. Today we're going to talk about one of the absolute weirdest, and maybe one of the most useful objects in the entire cosmos, pulsars. These things are like the universe's ultimate clocks, and they're born from some of the most violent events you can possibly imagine.
But you know, our story here doesn't start with a known object. It starts with a complete and utter mystery. So picture this, it's 1967. A young PhD student, Jocelyn Bell, is digging through data from a new radio telescope, and she finds something that just shouldn't be there. A signal from deep space, pulsing with a regularity so perfect, it just couldn't be natural, right? So the first thought that pops into everyone's head is, could this be a message?
And that's where we have to start, with the discovery itself. Because this whole thing is a genuine cosmic detective story. And the very first theory about what this signal could be, well, it was so tantalizing, it was almost too wild to even think about.
I mean, listen to Jocelyn Bell herself. She said that while they didn't really believe it was aliens, the idea was definitely on the table. Of course it was. They even gave the signal a playful nickname, LGM-1, which stood for Little Green Men. Just for a moment there, humanity was staring down the barrel of what could have been the single greatest discovery in all of human history.
And once they found it, things moved really, really fast. The signal was first noticed in August '67, pulsing with this perfect clockwork precision. By November, they were sure it wasn't just some random noise. But the real game changer came in December when Bell found a second one, a totally different source in a completely different part of the sky. I mean, what are the odds of two separate alien civilizations beaming signals at us at the same time? Pretty much zero. So the Little Green Men idea was out, and by 1968, these bizarre objects had a new official name, pulsars.
Okay, so if it's not a message from aliens, then what in the world was it? Well, the real answer turned out to be somehow even stranger. This is where we get to the true nature of the signal.
So here's the deal. A pulsar is a neutron star. That's the supercrushed, incredibly dense core that gets left behind after a massive star explodes. But it's not just any old neutron star. This thing is highly magnetized, and it's spinning at insane speeds, shooting out these powerful beams of energy from its magnetic poles.
And that leads us to the absolute perfect way to think about them. Honestly, if you want to picture how a pulsar works, just imagine a cosmic lighthouse. Because it's not actually blinking on and off.
And the reason we see a pulse is actually pretty clever. See, a pulsar has two different axes. You've got the rotational axis, the one it spins around, and you've got the magnetic axis, which is where the energy beams are shooting out from. And here's the absolute key. Those two axes are not lined up. So as the star spins, those beams of energy sweep across space, just like a lighthouse beam. And if we on Earth happen to be in the path of that beam, flash, we see a pulse. Every single time it spins around, that's the signal.
So how do you even make an object this extreme? Where does it come from? Well, it all starts with one of the most violent events the universe has to offer, a supernova.
The recipe for a pulsar is pretty straightforward, but it's incredibly intense. First, you take a star, one that's way, way bigger than our sun, and you wait for it to explode. Second, the core of that star collapses under its own crushing gravity, squeezing the mass of an entire sun down into a ball of neutrons no bigger than a city. And third, and this is the cool part, because of something called the conservation of angular momentum, it's the same reason an ice skater spins faster when they pull their arms in, that collapse spins the new neutron star up to unbelievable speeds, sometimes hundreds of times a second.
Okay, so they're weird, they spin super fast, but here's the thing. Pulsars are so much more than just cosmic oddities. That incredible regularity has turned them into one of the most powerful tools we have for studying the universe.
I mean, the list of what we can do with these things is just wild. By timing the pulses from a pair of pulsars orbiting each other, scientists got the very first indirect proof of gravitational waves, and that work won a Nobel Prize. And get this, the very first planets ever discovered outside of our solar system, they were found orbiting a pulsar. We even use their signals to map the empty space between stars. It's an incredible toolkit.
And when we say they are precise clocks, we are not exaggerating. Just look at this number for the pulsar J0437-4715. That is an absurd, almost unbelievable level of precision. What's truly incredible is that the stability of these millisecond pulsars can rival and sometimes even beat our absolute best atomic clocks right here on Earth.
So all of this incredible precision is now powering the next great frontier in astronomy. We're now using pulsars to listen for the faint ripples in the fabric of space-time itself.
And they're doing it with something called a pulsar timing array. The idea is brilliant. By carefully monitoring a whole network of these super-stable millisecond pulsars spread all across our galaxy, scientists have basically built a gravitational wave detector that's the size of the entire Milky Way. They're looking for these tiny, coordinated changes in when the pulses arrive, because that would be a telltale sign that a gravitational wave, maybe from two merging supermassive black holes, has just washed over our part of the galaxy.
It's just amazing when you think about it. We went from a mysterious signal that we thought might be little green men to understanding the physics of a cosmic lighthouse, and now we're using those very same lighthouses to build a galactic-scale observatory. It just leaves you with this one really thrilling thought. What other secrets about our universe are these incredible cosmic clocks going to help us unlock next?